Good morning everyone, this is BremSter, and today I'm coming to you with a puzzle called Goo Peashooter by Ridhwan. I don't know why it's called that. It was never told to me. I don't know why. Um, I I don't know. I don't know. Um, I'm going to get on with the puzzle. Now, I do know, I'm pretty certain that the day this puzzle comes out is the day that you may have noticed that a new series has started on the channel. Yep, I'm releasing videos for March of the Quads, which was a puzzle pack that was released back in, I think it was actually March in 2022. So over 2.5 years ago now. It was pretty much the first major puzzle pack released through my channel. It consisted of 40 puzzles and it was incredibly popular. Now, one of the things about March of the Quads is I think about 8 of the puzzles from March of the Quads have been featured on the channel before, but I wanted to sit down and record March of the Quads again. And actually starting early March this year, I started recording these puzzles. And then we did Quads on Parade and I stopped recording March of the Quads to do that. And then I came back and did March of the Quads. And I have re-recorded everything, even the puzzles that had previously been featured on the channel. I have re-recorded, and because I wanted to solve the pack again. And when I've done those videos, I've mentioned that when those videos come out, I will post a link to the previous solves of those puzzles, so you can pick which one you wish to watch, or you could watch both, or however you wish to go with it. Link to the puzzle pack is listed. The whole thing is will be available. The videos are coming out one at a time. These videos have been available to channel members pretty much since I've recorded them, including some of them since March this year. But they are now coming out one a day for everyone, for free. Well, for YouTube. So yeah, you don't have to worry about that. So yeah, those will be coming out between now and Christmas, next 40 days. So yeah, hopefully you enjoy those. Let's have a look at Goo Peashooter by Ridhwan. Okay, so we have normal Sudoku rules apply. In every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. Digits on a purple line, including the 2 circles, must form a set of consecutive non-repeating digits in any order. So they are Renban lines. So this is a Renban line and must form a set of consecutive non-repeating digits in any order. So they could be 1, 2, 3, whoops. They could be 1, 2, 3, 4, 5. They could be 2, 3, 4, 5, 6. They could be 3, 4, 5, 6, 7. They could not be 2, 4, 5, 6, 7, because if you were to take those digits off and sort them, they wouldn't be a consecutive run of digits. And they couldn't just be 4, 5, 6, and 7, because they are then one of those digits would have to repeat. Purple lines are also split P lines. The value of the cells on the purple lines connected by the 2 circles, so the value of those, is equal to a concatenation of the 2 values in the circles in some order. E.g., 3, 3, 4, 6, 1 is valid, well, not on these lines because of the Renban property, but 3, 3, 4, 6, 1 is valid because 3 plus 4 plus 6 equals 13. Right. So what that means is, right, so if these were 3, 4, and 6, and these were 1 and 3, 3 plus 4 plus 6 is 13, and whatever these 2 digits are read as a number. So they're a bit like pill arrows in that regard, except the pill has been split up. Right. Oh, split P, because often I've heard it called with the, right, I get split P lines now, because I've heard the arrows often called as, not as pills, but as Ps. I've heard that done before. So what they're doing is they're splitting the pills or the Ps on the arrow so that they're on either side of the line rather than at one end. So it's like a double, it's like an arrow, but the 2-digit pill or the 2-digit P has been split. So instead of a pill, it's a P on each end. I like it. Okay, I think I've done a split P before, possibly as a quadro quadri or quattro quadri. Okay, and then the inequality symbol points to the smaller of the 2 digits. So this digit is smaller than this. Note, to clarify, row 6, column 7 connects to line to row 9, column 5. I think that's an error. I haven't reset this puzzle. Row 6, column 7. Oh, to that. Yeah, that, and that. It's not like that dog legging like this. Yeah, this line is part of this line. Sorry, yeah. This line and this line are the same, and that line and that line are the same. Yeah, you could have possibly used a slightly different color. I possibly would have used a little bit more blue in that line, but these are all things. Okay, so yeah, this line and this line are the same. This line and this line are the same. Right, okay. I think that's pretty clear. People are fairly used to this, though I like the clarification. I would normally use a slightly different color. It's all good. I'm going to restart the puzzle to restart my timer. Let's give this a shot. So, we know this is a 9-cell long Renban line. So we know it's going to contain no repeated digits. So it's all of the digits from 1 to 9. So we know its sum is 45. So, but we can express these lines as a formula because these cells here have a sum which is those cells there. One of those is a tens digit and one of those is a units digit. So let's say this digit was the tens digit and we expressed that as x, and this digit was the units digits and we expressed that as y. Then what we have here is we have 10x. I can't do that, but anyway, we have 10x and 1y. But on here, we would have 1x and 1y. Because if this read, say it was, let's just pick a number. I know what the number's going to be, but let's say it was 25. Then this would be 2, this would be 5, and this would sum to 25. So this would be 25. This would be a 2, so we have to multiply it by 10. No, this is what's multiplied. Yeah, because this sums to 25, this is x. What we end up with is the line, this has 10 times this. This, because if this is 2 and this is 25, then there is 11, because this is a tens digit, because, how would I express this? Sorry, I'm terrible at explaining mathematical concepts, and I'm aware of that. Because if this was a 2 and this was a 5 and this was 25, what we end up with is the line would sum to, what would that be? The line would end up summing to the wrong value, because this would be 2, this would be 5, this would be 25, the line would sum to 32, which is wrong. But if you think about that, 32 is 2 times, if we do x being 11, because we have to multiply this by 10 for it to count, or it's this by 10, and then this by 1, we end up with 11x. I'm trying to think how to explain this better. But it's 11x plus 2y, because this is 10x and 1y, this is 1x and this is 1y. That's how you do it. Because this line is 10 times x plus 1 times y. Because if this is 25, it's 10 times x, right, so yes, this is 10 times x and 1 plus 1 times y. This is 1 times x and this is 1 times y. So we end up with 11x plus 2y. I'm actually going to note this. Let me get my note thing. So it's 11x plus 2y. And that's what these lines are always going to be. But we know this line is 45 because it's all of the digits 1 through 9. So if x can't be 4, because if x was 4, then we would need x, then the 11x would be 44, and 2y would have to equal 1, and y would have to be a half. It doesn't work. If x was 3, then 11x would be 33, 2y would be 12, and it'd be 36. And I think that's what it has to be, because if x was 2, 11x would be 22, 2y would have to be 45, would have to be 23, and that doesn't work. So x is, right, so these are 3 and 6. Let me get out of letter mode. Are 3 and 6. And the reason they are 3 and 6 is because if x is 2, then I'm only at 22, 2y has to equal 23, and the value is too high because the maximum 2y can be is 18. If it was 1, then 2y would have to equal 1 and y would have to be a half. It doesn't work. So x has to be 3, which means that 2y, which leaves me with 33, 45 minus 33 is 12, so 2y has to equal 12, so y has to be 6, and these are 36. Now I have to do the same for these other lines, I expect. So, and these are a lot less locked in, because on the 9-cell line, I knew exactly what digits were on it, but I don't on a 5-cell line. So on a 5-cell line, it could be 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 5, 6, 7, 8, 9. They're the 5 possibilities. So if it's 1 through 5, the total would be 15, because if you add 1, 2, 3, 4, and 5, you get to 15. You then have, x would have to be 1, because if x was 2, 11 times 2 is 22, which is above 15, so it doesn't work. So if x was 1, if it's 1 through 5, x is 1, which means you're at 11, so it'd have to be 1, 2 at the ends. I'm going to make, and then, so if it was 1, 2 at the ends, 1, 2, and then 3, 4, 5 would be on the line. 3, 4, 5 does sum to 12, so that would work. Okay, so if it's 1 through 5, it's 1, 2 at the ends with 3, 4, 5. If it's 2 through 6, the minimum 2 through 6 sums to, well, 1 through 6 is 21. We've removed a 1, so it's 20. But the minimum x could be would be 2, which means x would be automatically 22, but the whole line would sum to 20. So that doesn't work. 3 is going to be even worse off, isn't it? Because if it's 3 through 6, I'm adding 5 to the line each time. Sorry, 3 through 7. 3 through 7, well, 1 through 7 is only 28. But if x, the minimum of x is 3, the minimum that 11x could be would be 33. Even if it was a 7-cell long line, I'm too wrong. 4 doesn't work automatically because 44 doesn't even work on a 9-cell line. So x could only ever be 1 through 3 on the puzzle. On any of these lines, ooh, I think these are going to have to be almost 1 on almost all of them, but there might be possible to be 2 on some of the longer ones. But on this one, it has to be, it can't be 2, because 11 exceeds 22, but the maximum a 2 long line could be is 20. So this is 1, 2, 3, 4, 5. Now, are there any other 5-cell long lines? This is a 5-cell long line. So this has to be 1, 2, 3, 4, 5. How long is this line? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we want to look at the 6-cell line. So on the 6-cell line, if it's 1 through 6, we know that the line sums to 21, because if you add all the digits 1 through 6, you get to 21. Now, I haven't even done any Sudoku yet. This is just doing split P lines with Renban. 21. If x is 1, you're at 11. If x is 1, you're at 11. And then you've got 10 left over. So 2y would be 5. So it would be 1, 5. 1, 5. And then left on the line would be 2, 3, 4, and 6. 2, 3, 4, 6 does sum to 15, because 1, 5 would be your digits in the circles, and 2, 3, 4, 6 does sum to 15. Now, if x was 2, it doesn't work, because 11x is 22, but we're aiming for a 21 line. Now, 2 through 7 1 through 7 is 28, and I remove a 1, leaving me with 27. 11x is 20. If x is 2, is 22, leaving me with 5. And I can't divide 5 by 2 for the 2y, so that doesn't work. 3 through 8. Well, 3 through 8. 1 to 8 is 36, and then I have to remove a 1 and a 2, which drops me back, which is removing 3. So I drop it back to 33. But 11x would be 33, and then the 2y would have to sum to 0. That doesn't work. And 4 doesn't work at all, because if I'm doing 4 through 9, I'm looking at 45 minus 6, which is 39, but 4x is 44, and it doesn't work. So once again, I'm forced to use a 1, because if I use x equals 2, then, what was it? It was, if x equals 2, I was at 22, I was aiming for 28 minus 1, 27, so I'd need 2y to equal 5, and y would have to be 2.5, which doesn't work. So I have to use the 1, 5, and these are 2, 3, 4, and 6. Now, there's no 3 or 4 here because of the 3, 4, 5. This is the 2, 6. There's no 2, 6 here. This is the 3, 4. Looking up, making this the 5, taking the 5 out of here. This 1, 2 is different, which means this is the 5, which means this is the 1, which means this is the 2, which means this is the 1. The 1 makes this the 2, which makes this the 1. Okay. So now I'm looking at this 1, 2, 3, 4, 5, 6, 7 cell line. So if it's 1 through 7, let's make a note here. 1 through 7, that's a 28 line. Now, if it's 28 and x is 1, then 11x would be 11, and 2y would have to equal 17. That doesn't work. That doesn't work. Yeah. So with all the others, it's had to equal 1. But with this one, I don't think it can. If it's 2 through 8, I add 8. Well, hang on. 1 through 8 is 36. And then I remove 1, so I'm aiming for 35. Now, if x equals 1, then I'm at 11. 35 minus 11 is 24, and then 2y would mean y is 12. That doesn't work. If x is 2, I'm at 22. 35 minus 22. 35 minus 22 is 13. That doesn't work. Have I messed up my maths here? If x is 3, so... No, hang on, x could be 3. If x is 3... No, x can't... I must have messed up my maths somewhere. Oh, I thought I was going so well. If x is 3... it'd be 33. I'm aiming for 35. I'd have 2 left over, and it'd have to be 3, 1. But I can't put either 3 or 1 here. Because 3, 4, 5, and 1 are already taken up in this box. So what if it's 3 through 9? Surely that can't be right, can it? If it's 3 through 9, it's 42. I couldn't use... 1 because then 2y would have to be 31. I couldn't use 2 because then 2y would have to be 20. If it was 3, then I'm at 33. 2y would have to be 9. That doesn't work. And if it's 4, that doesn't work either. I'm broken. If it was 1 through 7, did I mess this up or did I mess up earlier? If it's 1 through 7, 1 through 7 is 28. That's right. Yeah, 1 through 7 is 28. 1 through 5 is 15. Add 6 is 21. Add 7 is 28. If x is 1, I'm at 11. I can't have... If I remove 11 from 28, I'm at 17. That doesn't work. If x is 2, I'm at 20. Oh, hang on. No, if x is 2, I'm at 22. If x was 2, I'm at 22. 28 minus 22 is 6. And that means it's 3. It's 2, 3. So if it was 2, 3... How did I miss this? 2, 3. That would leave 1, 4, 5, 6, and 7. 1, 4, 5, 6, and 7. 6 and 7 is 13. 1, 4, 5 is 10. Add 13. That's what it is. So these are 2 and 3. And I know the order because I can't put 3 here. This is 2. This is 3. These are 1, 4, 5, 6, and 7. The 3 looks up making this the 6, which makes this the 3. 6 comes out of all of those. The 6 is in here. The 1 comes out all of those. The 1 is in here. It's 2, 3. These are 2, 3, 8, and 9. There's no 2 in any of those. 2 is in one of those 2. I missed that as an option. Sorry, everyone. Can I do more Sudoku? Sort of. 1 is in one of those 2, so 1 is down here. Six is in one of those. I probably should finish this. So what's the 7 cell line? If it's 1 through 8, it's 36. Now, x couldn't be 1 because 2y would have to equal 25. That doesn't work. If x was 2, 22. 36 minus 22 is 14. So it would be, let's make a note here. It would be 2, 7. 2, 7 is 22 plus 14, which is 36. So to be 2, 7 with 1, 3, 4, 5, 7, 8. 1, 3, 4, 5, 8. I've used the 7. 1, 3, 4, 5, 6, 8 is what it is. Now, 3, 4, 5, 6, 8. Does that equal 1, 3, 4, 5, 6, 8? Does that equal 27 is the question. And this is where my math is terrible. So 1 and 3 and 4 is 8 plus 5 is... What's happened to my head? It's 13 plus 6 is... 1, 3, 4 is 8, plus 5 is 13, plus 6 is 19, plus 8 is 27. So that does work. So that's if it starts with a 2. If it starts with a 3, I'm at 33, and I need 2y to equal 3. That doesn't work. Okay, what about 2 through 9? 2 through 9, well, that's easy. It's 44, because it's 45, 1 through 9 minus the 1. So it's 44. So I couldn't use a 1. The minimum x could be, it'd be 1, but 2. So 22 doesn't work because I need to get to another 22. 2y, y would have to be 11. If it was 3, it'd be 33. 2y would have to equal 11. That doesn't work, and 4 doesn't work. So it has to be 2, 7. These are 2, 7. So that's a 7 and that's a 2 because I can't put the 2 there. And the digits on it are 1, 3, 4, 5, 6, 8. So there's no 2 on the line and there's no 9 on the line. This is a 3-8 pair. So there's no 3-8 there. That's the 9. That's the 2. That's really cool. And these are 1, 3, 4, 5, 6. These are 1, 4, 5, 6. So the 4, 5, 6 comes out of there. This becomes the 6. And the 4, 5 makes that the 7. And I can take the 7 out of those. That's really clever. This is a triple. 1, 2, 3, 4, 5, 6, 7. This is a 7, 8, 9 triple. But that's all of the lines determined. There's no 5 there. That's all of the lines determined. Assuming I haven't made an error. The 6 comes out of here, so 6 is absolutely in one of these. Two on this diagonal is on one of those two cells. It could be diagonal trickery. What are these 3 cells? Because they're not 1, 2, 3, 4, 5, 6, 7. These are 3, 8, and 9. 9 must be up here. 3 can't be on the line. So that's just an 8 or a 9. Oh, the 3, 8 takes 3 out of there. 3 is in one of those two. These are 6, 7, 8, 9. Well, this is an 8 or a 9 then, because it sees a 6 or a 7. There's no 1 there. Okay. Eight is in one of those two because 3, 8 looking across saying 8's not in any of those. 8 is in one of those two. 6 is in one of those. There's something, it's probably diagonal, you know. And I'm not seeing, like the 5 and the 7 are in those cells. The 5 is in one of those two. That could be a 5-7 pair though. Once I add the 7 in, I can pick up that one. Like, I wonder if there's any, like that can't be 1, 2, 3. I wonder if there's any naked singles. Like this can't be 1, 2, 3. It could be 4. Can't be 5, 6, 7. 4, 8, 9 is all that. And it can't be 8. That's just a 4 or a 9. Can't be 8 because of the 8 looking up here. One, two, three, four, 5, 6, 7, 8, 9. Can't be 9. This is 6, 7, or 8. There's something going on. I bet you there's just simple Sudoku I've missed. Oh, yes. Like that 3, looking up, making that the 4 and that the 3, saying that's not the 3. So this is an 8, 9 pair, meaning that's the 3, that's the 8. The 8, 9 pair makes that the 7, which now I can ask where does 7 go on this diagonal? It's in one of those two. These are 1, 3, 4, 5. There's no 3 there. There's no 5 there. There's no 4 there. There's no 4 there. This is a 1 or a 5. 4 is in here. Okay. This isn't a 3. That's a 1, 5 pair. So that's the 4. That's the 3. This is a triple. 1, 2, 3, 4, 5, 6, 7, 3, 8, and 9. Well, there's no 8 there because of the 8 looking up. There's no 6 there because of the 6 on the diagonal. Right, yeah. Cool. These are 4, 5, 8, 9. That can't be a 4 or a 5. So I've got an 8, 9 pair, so there's no 8, 9 there. Couldn't be a 4 and it couldn't be a 5. That's cool. Five could still be in either of those two, I think. Huh. Two in this column is there or there. This is a triple. 1, 5, 7. So hang on. Yeah, this is an 8, 9. These are 1, 5, 7. There's no 5 there. There must be a 7 in there. That has actually done less than I thought. Because this 8, 9 pair was resolved. Well, not resolved, but that was there. 2 is in one of... Oh, no, 2 is placed. 2 is right there. So these are 4, 5, 6, and 7. There's no 5 in any of those. That's the 5. This is a 4, 6, 7. So these are 1, 8, and 9. So there's a 7 in one of those two. These are 7, 8, 9. So now I've got a 7, 8, 9 triple. So this is 2 or 6 only. Because 1, 2, 3, 4, 5, 6, 7, 8, 9. I can see 2 is in one of those two. It's got to be something to do with this diagonal, because it's basically just a diagonal. Like, I can't repeat any digits along it. 1 is in one of those two. But 1, if this is a 1, that's a 1. That's a 2. 2 and 2 looking into this box. That is a 2. Yeah, what I haven't resolved is just that X-wing on 2s. Seven, no. I mean, this is going to end up doing something, but I'm not sure how. Because this being an 8 gives that so much freedom, it's not funny. And I don't seem to have a restriction on that cell yet. it could be almost anything. Oh, do I want to pencil mark this? It could be 1, 4, 5, 6, 7. It can't be 8. It can't be 7. It's 1, 4, 5, 6. And I already knew this was 6, 7, 8, 9 because these are all. These are 6, 7, and 9 because they can't be 8, and these are 6, 7, 8, 9. 6, 7. Oh, there's no 9 there. That's 6, 7, or 8. That doesn't seem to do much, does it? Scanning fail again? This 7 is saying that's not the 7. I know 7 is in one of those two. Okay, what digits haven't I put on the line? I could put the 1 there, I think. So the 1 is in one of those two. 2 needs to go on the line. It could go... Oh, where's 2 on the line? 2 is not on the line in either of these boxes. 2 has to go the line here. It's not here and it's not there. That is the 2. This is the 7. This is the 6, which means this is the 2 and this is the 6. This 6 means this isn't 6. This is... This inequality sign, it's not doing anything. Because I haven't used the inequality. Maybe I did remove an option using the inequality to get it down to this. I don't know. But there's no 6 here. This is a 7, 9. So this is the 8. This is the 6. These are 1, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7. This is the 8. So this is the 9. 7 and 9 look up, making that the 8, taking 8 out of all of those. The 1, 9 makes that the 7. The 8 makes that the 9, that the 8. This is a 1, 9. This is 1, 4, 5. There's no 4 in it. 6 looks up, taking 6 out of there. That's a 4, 7, 9 triple, so that's the 3. So on the line, 1, 2, 3, I'm confirming it's 1, 4, 5, 9. 1, 2, 3, 4, 5, 6. Yeah, 1, 4, 5, 9. These are 1, 4, 5, 9, but I can't put 5 in this box. So that's the 5, that's the 1. 1 comes out of those. This is 4, 5, 6. 5 comes out of those. This is 1, 7. One, 4, 9. So this can't be the 1. So this is the 1. This is a 4, 9 pair. So 9 can't be in any of those or any of those or either of those. That's the 9, that's the 8. Okay. Yeah, I may have used this. It just feels like I didn't, possibly because I used it to just eliminate a high option, like to take 9 out of it. 6 is in one of those two because of this. What is this triple? 3, 6, 8. Well, there's no 8 in either of those, so that's the 8. That makes this the 6 and this the 3 from this 3 looking over. That 6 says that's not the 6, that's the 6. That removes both of those 6s, so this becomes the 6. This is a 4, 5. So 4, well, this 1 makes that the 7 and that the 1, but now 4 isn't in any of those or any of those, so 4 is over here, which means that's the 4, that's the 3. This is an 8 or a 9. This is 159? Yeah, 159. 3 is looking down saying 3 is not there. That's the 3. Six is looking up saying that's not the 6. This is a 4, 7. That's the 6. The 5 is looking down, making that the 4, which makes that the 5, which takes 5 out of both of those. This still could end up being a colouring puzzle, couldn't it? I'm not sure. 4, 5, 8, 9. This is 4, 5, 8, 9. So it's 5, 8, 9. This is the only cell I haven't pencil marked, which is, well, there's no 1 here. 4, hang on, that's a 4, 5, 9 triple. So this is an 8 for the row. So that makes that the 9. The 8 and the 9 makes that the 5, and I'm broken. Now, what have I done wrong? What have I done wrong? There's no 1 here. 1, 2, this has to be the 8. I've made a boo-boo somewhere. That's the 9, that's the 5. 1, 2, 3, 4, 5, this is a 7. The 9 makes this the 1. I think I went wrong when I pencil marked that cell. The 1 makes that the 4, which makes that the 5, which makes that the 1. The 1 and the 4 makes that the 5, that the 4, that the 1. Seem to be good so far. The 5 makes that the 4 and that the 5, which looks across making that the 9 and that the 4, which makes that 7 and that the 9. The 7 looks up making that the 4 and that the 7. The 9 looks across making that the 8 and that the 9. Holy cow. The Sudoku at the end there was quite tricky. Minimalistic places. I must have used that to just eliminate a high digit from that cell while pencil marking without barely registering that I did it. The math on these, not too complex. It's similar to a lot of double arrow, or not double arrow, but arrows with pills logic that we've seen before. But this line kind of gave it away how you had to do it with the 11x2y. And then I just needed to wrap my head around what the possibilities of it were. They were quite constrained. And again, people who are just lightning quick at the algebraic math are going to be able to fly through this one. So again, there's going to be a lot of comments about people doing this. It took me, 36 minutes? There'll be a lot of comments about people doing this in 20 or less. That's just the way it goes. They're also not explaining it. And yeah, again, that's just the way it goes. The important thing is I brought the puzzle to you, and that's what matters. Hopefully the solve count... What's the solve count on it? 39 in 43 days. I'm sure we can get that higher. Thanks everyone for watching. Hope you enjoyed the puzzle, and as always, good luck with your solving.